Hello Year 8, we're going to have another look at some digital images today, and we are moving on from bitmaps to look at something called a vector image. So our LI for today is to understand how computers create vector images. So just to recap quickly on bitmaps, remember it's exactly what it says it is a map of bits. So we've got our grid of pixels, and then the bits of binary sit inside the pixels and tell each pixel what color to be. So every single pixel has got its own bit of binary code, and that's how it remembers. That's how it's stored as to what that image is made up of. But there is another way, and that's where vector images are going to come in. So a vector image uses shapes such as straight lines, curves, squares, triangles, quadrilaterals, all sorts of different shapes. And it remembers where those shapes are and what colour they are by storing their coordinates. So for example, if we've got a really simple image like this, we've got a red line and a blue curved line. All it would need to remember is where the start of the red line is and where the end of the red line is. So you'd have the coordinates like 1, 1 and 3, 9. And then the same for the blue line, what colour it is, where it starts, where it ends, and then the shape of that line, so the curve of that line. Okay? And it would also need to remember in this image the white background as well. So it would say, oh, there's a white background that starts from here and stretches all the way across to there. So in a way, this can be a lot simpler than a bitmap because you've got to remember just the shapes and where they are. And that's great when we've got a simple image. Let me show you what I mean. So here's a simple image. You've got a Mondrian who's got lots of lines, got lots of black lines, and we've got lots of rectangles of different colours. So for a vector image, this is really good because you've got lots of areas that are the same colour. So in a bitmap, you need to remember each and every pixel individually, no matter if you've got lots of the same colour. It's going to store from top left, reading across all the binary for each pixel. But in a vector image, we can just store, right, what are the coordinates of this yellow rectangle? Right, that's there. What's the color of that rectangle? And once you've got that information, you've got all the pixels. Same for the red, same for the blue. You just remember the coordinates of the rectangle and then what color that rectangle is. Same for the lines. Where do they start? Where do they end? How thick are they? So this can be a really efficient way to store an image. Another advantage of vector graphics is that they can be scaled. They can be made larger or smaller without losing resolution. Because you just adapt the coordinates to fit onto a larger scale or a smaller scale, you never get that resolution issue that we saw with bitmaps. So if you look at the image below, when we start sort of stretching and trying to increase the size of a bitmap image, you can get distorted pixels. They get stretched, whereas a vector doesn't have that problem because it can always adapt the coordinates to whatever number of pixels, whatever resolution you want. However, there are occasions where a bitmap is going to be better. So for example, if you've got a very complex image that's got lots of different colors, that's got lots of different shapes, lots of small shapes, it's more efficient to remember it pixel by pixel than it is to do it by shapes. Because while storing a shape can be really good if you've got a large area, if it's a small area of only a few pixels, it's going to take a lot of binary to remember the coordinates of that shape and then the color of that shape over and over again. You've got lots of different shapes in that image. It takes up a lot more binary than it would to say pixel by pixel. So sometimes, if you've got a simple image, a vector is going to be better for efficiency and space. If you've got a complex image with lots of different colors that are really broken up into small pieces, then you're going to be looking at a bitmap being more efficient than a vector. Okay, whichever way it's stored doesn't matter, it's going to end up in pixels. So usually, most images you come across are going to be bitmaps. However, if you are working in a design program, what you may find is that actually they're more likely to work in vectors because they know that you're going to want to scale that image to larger or smaller. So it just depends on the job you're going to do, and it's just a different way of storing a digital image. One is not necessarily better than the other. Some are better in one situation, some are better in another situation. But you need to know that there are two different kinds. So hopefully you know what a vector image is. It's an image that's made up, it's a digital image that's made up of shapes that are stored what shape it is and what color that shape is, and it's done for the whole image. Hopefully you know that some of the advantages of vector images. So it's great if you've got an image that's got big blocks of the same color because it saves a bit of space doing that way. and it's good if you want to scale the image, make it bigger or smaller. Then you might be able to choose, so our goal, looking at when it'd be better to use a vector over a bitmap. So you might be able to explain why it would be, when would be a better situation to use a vector over a bitmap. And then a bit of a challenge is to explain how binary codes for a vector image. Okay, now what you're going to do today is you are going to be computers. So you are going to have a set of coordinates given to you and a grid, and you are going to draw out the coordinates and make a vector image. Okay, so by following the coordinates, you're going to make that vector image. By the end of it, you should have something that you recognize. Best of luck, guys.